Welcome to the DIY Honda Garage channel. The DTC P16F4 is related to the starter cut relay 2 control circuit, identified as having low voltage when the starter is off. This issue is crucial in the Honda Civic 2022 Plus, as it indicates that the powertrain control module, PCM, has detected an abnormality in the starter system. The starter cut relay serves to manage the power reaching the engine's starter motor, ensuring proper starting operations. If the signal from starter cut relay 2 is low while the engine is off, it can prevent the vehicle from starting, as the PCM recognizes this anomaly. Understanding the exact role of the starter cut relay and circuits involved is essential for an effective troubleshooting process. DTC P16F4 arises when the starter cut relay 2 return signal is low when the engine is off, which prompts the powertrain control module, PCM, to generate this trouble code. The primary components impacted by this error are the starter cut relay circuit board, and the PCM itself. The starter cut relay functions by allowing or disallowing power to the starter motor based on received signals. Its location is in the relay circuit board, which is generally found within the engine compartment or near the fuse box. The PCM is responsible for monitoring this circuit, making it integral to starting the car. Hence, an abnormal reading from this relay could indicate either wiring issues, a fault within the relay, or problems with the PCM's functionality. Several factors may contribute to triggering DTC P16F4, each implying a distinct diagnosis approach. A faulty starter cut relay may fail to send the correct signal, resulting in low voltage readings. Wiring issues, such as shorts or opens, can easily disrupt the communication between the relay and the PCM, leading to similar abnormalities. Additionally, if the PCM itself is malfunctioning, it may misinterpret or fail to read the signal from the starter cut relay correctly. Each of these possibilities contributes to the overall malfunction, hence requiring systematic checking to identify the root cause effectively. When experiencing DTC P16F4, the primary symptom is that the engine may not start at all. This is due to the PCM identifying that the starter cut relay is sending incorrect signals. There can also be intermittent starting issues if the circuit is partially functional, where the vehicle might start sporadically. Low voltage readings when testing the circuit further confirm the presence of this DTC. Drivers may also notice related electrical system anomalies, such as flickering dashboard lights when attempting to start the vehicle, indicating that troubleshooting is necessary to resolve the underlying electrical issues. For the first step in troubleshooting DTC P16F4, begin by confirming that the vehicle is in the on mode, as this readiness is crucial for proper diagnostics. This initial check allows the PCM to receive functional engagement from various components, including the starter cut relay. Next, assess whether the engine starts. If it does, it indicates that the problem may not be present at that moment. But if it does not, proceed to inspect the starter functionality and associated circuits. Look for any disconnections in the relay circuit that may be causing the low voltage signal. Understanding these conditions will guide further inspections and help trace the issue accurately. In the second troubleshooting step, focus on inspecting the external circuits involved, particularly the IG1 ST cut RLY and IG1 starter cut circuits. Disconnect the necessary connectors as indicated and ensure that the integrity of these connections remains intact. You should conduct tests to verify that both circuits maintain a normal voltage level. This should be around 12 volts during the on mode. It's crucial to also check jumper connections to ensure no short circuits exist, as these could cause improper voltage readings leading to the stored DTC. By isolating each component's operation, you enhance the possibility of accurately identifying the issue. During the third troubleshooting step, begin by appropriately disconnecting necessary connectors, especially targeting the relay circuit board connector and the PCM connector. This allows for a safe and effective inspection of the ST-cut RLY2CL signal line. Perform an open wire inspection. The goal is to ensure that there is less than 1 ohm of resistance when checking connectivity. If you find any shorts to ground, these need to be addressed immediately before proceeding to retest the system. A grounded circuit could prematurely trigger the DTC, thereby complicating the diagnostic process. Upon completing repairs associated with DTC P16F4, your final step involves verifying that the issues have been resolved successfully. Start by clearing the DTC codes from the PCM using the appropriate diagnostic scanner. After clearing the codes, perform a test drive of the vehicle to observe whether the engine starts reliably and to assess any abnormal operations. Confirm that the starter cut relay functions as expected under normal driving conditions. Should all parameters return to normal, the repair is considered successful and you can proceed with vehicle delivery or further assessments. Preventive maintenance plays a crucial role in avoiding DTC P16F4 from recurring. Begin by scheduling regular electrical inspections to check for any potential wear and tear that may affect vehicle functionality. Assessing the starter cut relay's functionality routinely will ensure it operates efficiently when called upon. Additionally, monitoring starter performance can help catch any underlying issues early, allowing for timely interventions before they escalate into more serious faults. Keeping your vehicle's electrical components in prime condition contributes significantly to facilitating a trouble-free driving experience. In summary, DTC P16F4 highlights a low-voltage signal from the starter cut relay 2, posing significant challenges to starting the Honda Civic 2022 Plus. Proper understanding of the components involved, such as the role of the relay and diagnostics of the PCM, will aid in resolving this issue efficiently. The troubleshooting steps provided offer a systematic method to narrow down the exact cause of the error code. Moreover, implementing preventive maintenance strategies will aid in mitigating future risks associated with electrical systems. By maintaining good practice in vehicle care, drivers can ensure longevity and reliability in their Honda Civic. Please like and subscribe to the channel. See you next time.